Hello students, welcome once again to our Akshar IIT Foundation, and already we have started the structure of the atom, and today we continue with the same chapter. In the previous class we discussed about the Dalton's atomic theory, and we have seen that the most important concept of the Dalton's atomic theory was that any matter is made up of a tiny particles called atoms, and atoms are indivisible, right? But it was disproved, means proved as wrong by J.J. Thompson. So, how this J.J. Thompson disproved Dalton's atomic model? That we are going to discuss today. So, students, J.J. Thompson, so here we see already in the last class we discussed that Dalton's atomic theory suggested that atoms was indivisible, means what, we cannot break the atom. However, the discovery of three fundamental particles named electrons, protons and neutrons inside the atom led to the discovery of Dalton's theory, right? So, what are those three fundamental particles? Electrons, protons and neutrons. These are the three fundamental particles which are present in the atom. Okay. So, this discovery of these particles disproved that Dalton's atomic theory. And among these three particles, the first particle discovered was electron by J.J. Thompson. So, how J.J. Thompson discovered this electron? Students, J.J. Thompson discovered electron by an experiment called discharge tube experiment. Which experiment? Discharge tube experiment. Okay, discharge tube experiment. What is this discharge tube experiment? See, this discharge tube experiment consists of one small glass tube. It consists of what? One small glass tube. Okay. So, this is one small glass tube like this. This is a small glass tube, right? And this glass tube is fitted with two metal plates, or we can say these two metal electrodes. And these electrodes are connected to high electrical sources, okay, like this high electric sources. And here it is fitted with the vacuum pump. And by operating vacuum pump, the pressure inside the glass tube is decreased, and at the same time the voltage, the potential difference, the voltage is increased to about 10 K, means what, 10,000 volts. 10,000 volts. At this time, J. Thompson observed that particles from the cathode are originated and they are traveling towards the anode. So, these particles, actually it was considered as rays initially. Later it was proved that those are not a rays, but those are the particles. So, here under these conditions, means what, under very low pressure, okay, and a high voltage, let us observe that some rays are started from the cathode and they moved towards the anode. So, as they are producing from the cathode, originating from the cathode, they were called as the cathode rays. Now, let us see very clearly. So, here you can see, students, here this is the J.J. Thompson's experiment. J.J. Thompson experiment. So, as I said, so this is the discharge tube. So, you can see here this is a discharge tube, and this discharge tube is nothing but it's a small glass tube, and inside it is fitted with the two metal plates. So, this is a metal plate, okay, which are called as the electrodes, and these electrodes are connected to high source of electricity, okay, so high voltage generator, and the plate which is connected to the negative terminal. So, see here, negative terminal of the battery, this is known as a cathode, and the terminal, okay, and the electrode which is connected to the positive terminal of the source, that is called as a anode, right? And now inside, as I said, so here one vacuum pump is operated by using which the pressure inside the gas is reduced, and at the same time the voltage is increased. When the pressure is approximately 0.01 mm of mercury and the voltage is about 10 kilovolts, it was observed that some rays are originated from the cathode, okay, and these rays are started moving towards the anode. As they are originated at the cathode rays, they were named as the cathode rays. As they originated from the cathode, so they were named as the cathode rays. So hence this experiment is called the cathode rays discharge tube experiment. In this way, J.J. Thompson discovered the electrons. Is this clear? So that's about the discovery of electrons. Now, what are the properties of electrodes? What are the properties of electrons? So students, so let us see this once again, the J. Thompson experiment. J. Thompson and others conducted experiment to a vacuum pump. Metal electrodes are fitted at the end of the glass tube. He created a very low pressure, this is very important, inside the discharge tube and applied high voltage. At that time, a greenish rays are started and they move towards the anode, and these rays are emitted from the cathode, hence they are called as a cathode rays. So the stream of rays emitted from the cathode, hence they are called as cathode rays, which are made up of a small particles called electrons. So that is the discovery of electrons. Clear? Now let us see what are the properties. So this is a very, very important topic. So in your 9th class, you have only just discovery of electrons, but you don't have in detail at what experiment led to the discovery of cathode rays or electrons and what are the properties of cathode rays in detail. So here now I am going to explain you the properties of cathode rays in detail, right? So it's a very, very important topic. So let's see the properties of cathode rays. Cathode rays are produced at the cathode, and also already told you that cathode is an electrode which is connected to the negative terminal of the source. So as it is negative terminal of the source, the rays which are releasing or emitting from the cathode, those rays or those particles consist of negative charge. Hence, the cathode rays are produced from the cathode, that is what, negatively charged electrode, and they are moving towards the anode, means what, they are moving towards the positively charged. So cathode rays are negatively charged. This is the most important thing. So cathode rays are nothing but electrons, and these are the negatively charged particles. So electrons are the negatively charged particles because they are originated from the negatively charged electrode, that is cathode, and they are moving towards the anode. You know that they are okay. Now these cathode rays travel in a straight line. So here you see these cathode rays, they are traveling in a straight line. How can you say that cathode rays are traveling in a straight line? So what he has done is he kept a small cross, a small metal cross he kept in the path of the light, means the path of the cathode rays. So cathode rays are moving in this direction, let's imagine. So here what happens, the cathode rays are moving, just like a light, and you know that when the light is traveling, in a path, if you put something opaque object in the path of light, then what happens, this opaque object stops this light rays, so a shadow will be created. A shadow is formed behind the opaque object, right? So similarly, here in the path of cathode rays, this J. Thompson arranged one metal cross, and he observed that exactly behind of that the shadow of the cathode, the shadow of the metal cross, it was observed. The meaning is what, the cathode rays are traveling in a straight line. Is this clear to you? So this is one more property, that cathode rays travel in a straight line. Now here cathode rays are negatively charged particles. Okay, so they consist of negative charge. How can you prove that negative charge? So here see students, in the absence of electric or magnetic field, means if there is no any other electric field and magnetic field, it was observed that the cathode rays are moving in straight. Yes, the cathode rays are moving in straight. But J.J. Thompson what has done? Here he arranged okay, the charges. He arranged he fixed the electric fields on either side of the discharge tube. So here you can observe here he arranged one okay negative charge here and positive charge on either side of the discharge tube. Clear? So actually what was we observed, the cathode rays are moving straight, but as he arranged the two okay electric fields, opposite charge electric fields on either side, it was observed that instead of moving straight, these particles are deflected towards the positive charge. They deflected towards the positive charge. Okay, and you know that like charges repel, unlike charges attracts, opposite charges attracts. So here they are attracting towards the positive charge. The meaning is what? The other charges are negative charge, opposite charges attracts. So these particles are attracted towards the positive charge. The meaning is what? Those particles are negative. So in this way, he also proved that cathode rays are the negatively charged particles and they are attracted towards the positive charge and they are repelled by the negative charge. Similarly, cathode rays can possess the momentum and kinetic energy. What is the kinetic energy? Kinetic energy means the energy produced or the energy caused due to the motion of an object. Due to the motion of an object is called kinetic energy. So here, for example, if I have a light wheel, you know the wheel? Wheel, okay? If I place in the path of the light, does wheel rotate? No. Light do not have, okay, the energy to rotate the wheel because light is not a particles, right? But here what J. Thompson has done, he kept one small light wheel in the path of the cathode rays. Then when these cathode rays are striking to this wheel, then what happens? They created the mechanical energy. Means what? They created the motion in the wheel. So from this experiment we come to know that these are not a race, but these are the flow of particles. Cathode rays are not a race, but these are the flow of particles because they are creating the kinetic energy. Okay, so cathode rays also produce the heat when they allowed to fall on the matter. When the cathode rays falls on a matter, they also create the heat. So these are the properties of the cathode rays, students. Is this clear? So J.J. Thompson's experiment is very, very important because J.J. Thompson was the first person to say that atoms are divisible, and he proved this by using the discharge tube experiment. Through the discharge tube experiment, he proved that atom consists of a negatively charged particles called electrons. But if you ask where lies this electrons in an atom, so to explain that, he proposed one atomic model, and that model is known as Thompson's atomic model or plum pudding model or watermelon model of atom. So Thompson's atomic model, how it looks like is, so what he expected, so he discovered only electrons. He don't know about the positive charge at that time. But atom is overall neutral. Overall neutral means what? It neither positive nor negative. So the meaning is, but he discovered the electrons, which are negatively charged particle. If atom should be a neutral, then there should be equivalent amount of positive charge to the electrons, because electrons are negatively charged particles. If only electrons are present in an atom, then atom should possess only negative charge. Yes, but atom is neutral. The meaning is what? There is some positive charge which is equal to the negative charge, right? So what he thought, what he expected, okay, that atom is like a sphere. and this sphere is with the completely with a positive charge. Okay, so atom is like a positively charged sphere, means the total positive charge is present in the atom, and in that term electrons are present. In that electrons are present. So how can you understand very easily? So you can see that, you can see the watermelon. You know the watermelon? Okay, so watermelon. And how the watermelon is? Watermelon is spherical in shape. Alright. When you cut the watermelon, what do you find? A red coloring mass is present throughout the watermelon, right? So this red coloring mass is nothing but a positive charge. Let imagine, okay? If you think, if you compare the atom with the watermelon, then watermelon, okay, is an atom, and if you cut inside, the total watermelon is distributed with the positive charge, sorry, red coloring mass. So here atom is distributed with the positive charge, and in that red color mass we can see the seeds. Yes or no? We can see the seeds, black color seeds. How these seeds are distributed or presented, embedded in the mass. Similarly here electrons will be present in the atom. So here you see this is the atom which is spherical in shape like watermelon, and see the watermelon, what do you see? The red coloring mass is there. So this red coloring mass is nothing but a positive charge, and in the red coloring mass what are there here? Seeds are there. How the seeds are present? Similarly electrons are present. So this is known as Thompson's atomic model. So J.J. Thompson was the first person to explain the atomic model. Is this clear? And of course there are the drawbacks are there in the Thompson's model, but J. Thompson model, okay, proved that atoms are indivisible, and then it is also led to the discovery of the protons and neutrons, etc. Is this clear, students? Okay, so we discuss the next topic in the next class, right? Until bye.